Hello, good evening, everyone. We'll wait for a few minutes to change the host.
Good evening, sir.
Good evening. Any numericals you practiced? Shita, Amrita, anyone? Any new numerical, different kind of numericals practiced? Guys? Guys, will you able to hear what I'm talking?
Yes, sir.
Yes
Yes,
or
sir.
no? Yeah. You able to see the screen?
Yes, sir.
See, the last class we just all of a sudden it went off. Anyway, yes, we are continuing where we stopped in the last class. After this numerical, I'm going to do a new thing that is not available in the textbook, but based on that, some questions are asking. Now, prove that one and only one out of n plus 2, n plus 4 is divisible by 3, where n is any positive integer. Where n is any positive integer. Who is going to explain this numerical? Anyone can explain the numerical? He is clearly saying out of these three, only one is the correct one. Prove that any one only correct, which is divisible by 3, where n is any positive integer. If I am taking n is equal to 1, I will get 1, 3, 5. If I am taking n is equal to 2, suppose if n is equal to 0, I will get the numbers are 0, sorry, positive integer. If I am taking n is equal to 1, I will get the numbers are 1, 3, 4. So here 3 is divisible by 3. So n plus 2 is divisible by 3. If I am taking n is equal to 2, I will get 2, 4, 6. In this case, n plus 4 is divisible by 3. N is equal to 3. If I am taking, I will get 3, 5, 7. In this case, n is divisible by 3. See, each and every number, any one of the expression only divisible by 3. At a time, two or more expressions are not divisible by 3 for any positive integer of n. So if I am taking n is equal to 4, the numbers are 4, 6, 8. So here n plus 2 is divisible by 3. So this I have to prove. Now question is clear. What you have to do? Guys?
Yes, sir.
Yeah.
Yes, sir.
Yes,
Right.
sir.
How we will do this question? How we will do this question? What is the first step to initiate this numerical? Given n is any positive integer, we have to prove for each substitution of n, one and only one can be divisible by 3. So if I am applying with a divisor of 3, if I am applying the Euclid division lemma, apply Euclid's division lemma, with a divisor 3. So what are the possible numbers we'll get? N can be equal to 3q, 3q plus 1, 3q plus 2, where q will be some whole number. Am I right, guys? Some whole number. Am I right? Guys, are you clear what I'm saying or any confusion? Guys, are you there, everyone?
Yes, sir.
Yeah, after this, what you are going to do? What is our aim? I have to prove any one will divisible by 3. Case 1. When n is equal to 3q. So this is divisible by 3, which is divisible by 3. So when you prove that n is equal to 3q is divisible by 3, compulsory you have to prove remaining 2 can't be divisible by 3. How you can prove? How you can prove remaining 2 things can't be divisible by 3? When n is equal to 3q, so my n plus 2 will be equal to 3q plus 2. That means which leaves a remainder 2 after divisible by when divided by 3. When divided by 3. After this, n plus 2 and n plus 4. If I am taking n plus 4, where my n is equal to 3q.
I can take n is equal to 3 plus 1.
Sorry? So, which will leaves a remainder? I didn't hear you. Please repeat again. Somebody is talking something. Remainder 1 when divided by 3. So, when n is equal to 3q, there are only 3 possibilities. Either it should be 3q, 3q plus 1, 3q plus 2. When n is equal to 3q, again I will get the 3 forms. One is n is equal to 3q, when n plus 2, n plus 4. In this case, when n as n, it is divisible by 3. So, n is divisible by 3 if it is in the form of 3q. 3q plus n plus 2, n plus 4 can't be divisible if n is 3q. Is it clear, guys, what I'm saying? So, n
Sir,
plus
can you explain once more, sir?
see here, this number can be written either 3q or either 3q plus 1 or either 3q plus 2. Correct?
Yes, sir.
So n is some any integer. So any integer with a divisor of 3, I can write in 3 forms that we already discussed in earlier classes.
Yes,
It
sir.
should be 3q plus 0, 3q plus 1, 3q plus 2. So, and here 3 numbers are there, n, n plus 2, n plus 4. So, if n is 3q, if n is 3q, what is my n? 3q. What is my n plus 2? 3q plus 2.
It's 2.
What is my n plus 4?
3q plus 4.
3q plus 4. Out of this, how many numbers are divisible by 3? What set is divisible by 3? Any one only divisible by 3 now when n is equal to 3q?
Yes, sir.
Because 3q plus 2 can't be divisible, because when if I am trying to divide with 3q plus 2, I am getting a remainder 2. If I am doing division with the 3q plus 4, I am getting a remainder 1. So 3q plus 2 can't be divisible by 3. 3q plus 4 also can't be divisible by 3, but 3q can be divisible by 3. So, for this case, the conclusion statement is if n is in the form of 3q, only n can be divisible by 3, n plus 2, n plus 4 can't be divisible by 3. See, what is the question requirement? Either one only should divisible by 3. Any one and only should be divisible by 3. So out of 3, for a first case, only n is divisible by 3. Now clear what I am trying to say?
Yes, sir. It's clear.
Yes, sir.
Now, second case. Second case. What is the second case? If n is equal to
N is equal to 3q plus 1.
3q plus 2, correct? So n plus 2 and n plus 4. So when n is equal to 3q plus 2, we are trying to divide with 3. Leaves a remainder 2. For n plus 2, 3q plus 2 plus 2. That is 3q plus 4. This can be written as 3 of q plus 1 in plus 1. So if I am dividing this one with 3, it leaves a remainder 1. If n plus 4, I am checking for n plus 4. So if I am taking n plus 4, my n is 3q plus 2 plus 4. This will be 3q plus 6. This is 3 of q plus 2. If I am dividing with 3, leaves a remainder 0. So it's a perfect division. So what is the conclusion statement I can write here, guys? After discussing this 3 number, if n is equal to 3q plus 2, where q is some whole number n comma n plus 2 can't be divisible by 3, but n plus 4 can be divisible by 3. So one and only one can be divisible by 3 for the second case also. Correct or not? Guys, got it what I'm saying?
Yes, sir. Sir, can you
Yes,
show
sir.
the case one once more, sir?
So anyone can try the case 3?
So can you go
Sir,
with
I
that?
have taken N is equal to 3q plus 1 also.
Yeah, that in that case which is divisible by 3?
Sir, N plus 2 is divisible by 2. Sorry, divisible by 3.
Correct. So 3 different cases, 3 different sets will be divisible by 3. So each and every time if we observe one and only divisible by 3, one and only means out of 3. So out of 3 expressions, either n or either n plus 2 or either n plus 4, one and only divisible by 3. Am I right?
Yes, sir.
What the logic of the question? Shall I go to the next one?
Yes, sir.
Yes, sir.
So case 3. What is the case 3, madam? You already done now. Can you say case 3?
Yes, sir. I have taken n is equal to 3q plus 1.
3q
Where-
plus 2 now. 3q plus 1.
Sir, you have taken 3q plus 2
Okay,
as
okay,
case,
okay. Sorry.
case 2.
Then it will be 3q plus 2. 3q plus 1. So
Sir, n plus 4 is equal to 3q plus 5.
n is equal to 3q plus 1. After
Yes, sir.
dividing with 3, a remainder is 1. If n is equal n plus 2, 3q plus 3, this can be
Remainder is
written as 3 of q plus 1. The remainder is 0. N plus 4, 3q plus 1 plus 4. This is 3q plus 5. This can be written as 3 of q plus 1 plus 2. Here the remainder is 2. See, even here also, n is not divisible by 3, n plus 4 is not divisible by 3, but n plus 2 is divisible by 3 if n is equal to 3q plus 1. Only n plus 2 can be divisible by 3. This is how we can conclude this question. Just make a note. Just a minute. I will start the next one. Guys, done? Guys, shall I go to the next one?
Yes, sir.
Yeah. Now, I need how to know the given number is a prime number or not. How you will know, guys? How to know the given number is a, see, for conclusion I am
Sir, if its
trying to
factors
say,
are only 1 and the number itself.
I'll come back to that question. See, this, how we can say this, one more conclusion. Suppose if n plus 2 is divisible by 3, n and n plus 4 is not divisible by 3. Suppose if n is divisible by 3, n plus 2, n plus 4 is not divisible. If n plus 4 is divisible by 3, these two are not divisible by 3. That means each and every case, one and only number is divisible by 3. That is the meaning of this question. Clear, guys? Guys, clear?
Yes, sir.
Yes, sir.
Now, I'm going to discuss. Yes, one is prime factorization, madam. If that is not, it doesn't have any factors, then I can say it is a prime number, correct? how to deciding a number, a natural number to be prime. Suppose if I am giving the numbers less than 100, it will be easy to say, because 1 to 100 we are having 25 primes. Anyone can give the quick numbers?
Sir, your voice is breaking.
Still breaking? It's good only connection. Still it is breaking, guys?
Sir, now it's fine. Sir.
Now it's fine.
Still it is breaking. Now it's clear?
Yes, sir, now it's clear.
Yeah. So we can write some numbers. You will get 25 numbers. So if I am giving a number, you can verify with this number. But if I am giving little bit big numbers without checking many numbers, how to quickly we can wind it up? It's very simple. Suppose if I am asking you to check, verify whether 251 is a prime or not. How you will do generally? You are going general method. What is the method you are following in general, guys? Sorry?
Prime factorization.
Prime
Prime
factorization.
factorization.
Then you are going to check with the 2, you are going to check with 3, you are going to check with 5, checking with 7, checking with 11. After that, you have to check with 13. Like that, you have to do. Am I right?
Yes, sir.
Usability
Yes, sir.
conditions. But how many numbers will check like this? Till what you have to check like this? Got it, guys? What I'm trying to say? Now, what are the prime numbers from 1 to 100? Anyone? Anyone can give? What are the prime numbers from 1 to 100? What are the prime numbers from 1 to 100? Madam, anyone can give? 2, 3, 5, 7. Next,
11,
11, 13, 17,
17,
19,
23,
23, 29,
29,
31,
31,
31,
37,
37,
41,
41,
43,
47,
47,
53,
59,
61,
51,
67,
67,
71,
71,
73, 79, 83,
83,
23,
89,
89,
29.
and 97.
There, you know?
yes, sir.
91,
97,
91 is the prime.
97,
No, sir.
97, sir.
97. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. One is missing.
Sir, you left 83, sir.
That's it. Here 83. Yeah. So if I'm talking about 251, you have to search any number can be divisible by 3. All these primes you have to check now, whether it can be divisible by this number or whether it can be divisible by this number. Correct?
Yes, sir.
Now, instead of that, there is a small process we can do. Suppose, for example, I have to decide. 251 is prime or not. So the step 1, find the nearest perfect square. Find nearest perfect square. Anyone can give the what is the nearest perfect square?
225.
225, sir.
15 square is
15
225.
square, sir.
16 square is 256. Correct? Am I right, guys?
Yes, sir.
Yes, sir.
So the given number is in between 16 square. So
Hey, we are in night session and so good.
15 square is less than 225. Now, this is a crucial step. Step 2 is the least nearest perfect square, the number which is less than 251, and the perfect square you have to identify. So 15 square. So the square root of 225 is the nearest perfect square which is less than 251. So you have to pick a number which is less than the given number and it should be a perfect square. So I got that square root is 15. So my m square is less than 251 where m is 15. So now what are the prime numbers up to 15? 2, 3, 5,
5, 7,
7,
11,
13.
13.
13. So there are 6 numbers. Verify any of these primes less than 15 is divisible by is divisible with can be divided with 251. If no prime can be divided with 251. Suppose if there is no number you are getting, there is no number you are getting, which can't be divisible by 215, then 251 is the prime. Suppose if you found anything, any one prime can be divisible by, any one prime can be divided with this 251, where it leaves the remainder is 0, then the given number is not a prime. Guys, clear? Or am I confused anything? Got it? Guys, I need some response from you, whether you
Yes,
understood
sir.
or not.
Yes,
Yes,
sir.
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 So, no need to verify till 250. Till 250, we are having so many primes. No need to verify all those primes. I'm not going to give the proof for this process. We want to know only the process to decide whether the given number is a prime or not. Now, I can use some numericals based on this?
Yes, sir.
Verify the following numbers are prime numbers or not. 101, 109, 119, 173, 197, 233, 247, 377. Guys, please proceed. First, anyone can give the how to do first question? The first question is 101. So nearest to perfect squares are what?
100, sir.
111, sir.
So 100 less than 101 less than
121.
So the least is 100. So 10 square is less than 101. So m is 10. So what are the primes between 1 to 10? 2, 3, 5, 7. Correct? check 101 can be divisible by 2, 101 can be divisible by 3, 101 can be divisible by 5, 101 can be divisible by 7. If all are giving some remainder, then it is not a prime number. Ma'am, class online class. Guys, what is the answer?
Sir, not a prime
Or it
number.
is
Sir, not a prime
Prime,
number.
prime. See, here you can apply your general divisibility rules, correct? Divisibility rules I can apply now. If it is
Yes, sir.
a even number, can't be divisible by 2. Sum of the numbers 1 plus 1 is 2, can't be divisible by 3. Not ending with 0 or 5, can't be divisible with 5. 101 can check with the 7. So my first question answer is it's a prime or not prime?
prime.
Not
It's a
Sir,
prime
not
number,
like
sir.
Prime.
Prime, not a composite number. So even 109 also same numbers only now, because 109 is less than 121 and greater than 100. So you cannot you have to verify only 2, 3, 5, 7. Am I right, guys? Or you have to check with any other numbers other than that 4?
Only that 4, sir.
Only that four, sir.
So it is a prime, sir.
Prime number, sir.
What about 119?
Same 4 numbers, sir.
Same 4 numbers?
Yes, sir. Because it comes under 10 square and 11 square, sir.
Correct. This also comes under 10 square and 11 square. Same 4 numbers. Check. It won't be divisible by 2. 9 plus 1, 10. 10 plus 1 is 11. It won't be divisible by 3 also, because the sum is 11. Not ending with 0 or 5. So it can't be divisible with 5. So only 7 you have to check.
Sir, it's divisible by 7,
So
sir.
it is composite
Answer
number,
is
sir.
17 if you divide it by
So to give a conclusion statement, 7 how many times?
17 times.
7 17 times is 117, 119. So 7 is a prime and 17 is a factor for this. So this is not a prime. What about 173? Guys, like that you can do all these 5 questions. I'm giving 5 minutes time.
Yes, sir.
Can you try? Yes. Just give the answers after completion of all the 5 numbers.
கொஞ்சம் டைம் ஆகும்.
Yes, anyone done all 5? Guys, still anyone got the answers?
Sir, doing last one, sir.
Last one, sir.
Hmm.
Sir, completed, sir.
Tell me 173 is lying between which perfect squares?
Sir, 13 square and 14 square, sir.
That means 169, 196. So what are the possible numbers here?
2, 3, 5, 7, and 11, sir.
Yes. So answer is
Prime, sir.
It's prime, sir.
prime. Here it is
15
in
square and
14
square and
square,
15
15 now.
square.
14 square to 15 square, correct?
Yes, sir.
So what are the numbers can be? I have to check.
2, 3, 5, 7, 11, and 13, sir.
11 and 13. So what is answer?
Prime, sir.
So prime. What about 233? Is it prime?
Sir, between 15 square and 16 square.
Between
15 square
square
and 16 square.
and 16 square. So the same kind of setup I have to check now. No need to check any extra, correct?
Yes, sir.
Yes, sir.
You don't need to.
So whether it is a prime or not.
Prime,
Prime,
only,
sir.
sir.
Times
What about 247?
It's
Sir, between
composite
15
number, sir.
square and 16 square, sir.
15 square and 16
And
square.
it's a composite number, sir.
How we can say it is a composite number?
Sir,
It's divisible by 13, sir.
Divisible by 13,
13 into 19, sir.
13 into
19.
19. So it's not a prime. What about 377?
sir, between 19 square and 20 square, and it's a composite number, sir. It's divisible by 13.
13 into
29.
29. See here. This is how we are going to verify even for little bit big number also. You can say, sir, where we can use. Using these strategies only, we are going to programming certain things. It's like 10-digit number, 20-digit number, 40-digit number to check whether it is a prime or composite. We are going to do a program. Because if numbers are bigger, like if I'm taking 100 squares, 100 square will use 10,000. So we can verify 10,000 using only with the 25 numbers, divisibility conditions. You can verify within 10,000 numbers what are the primes. If I'm taking 1,000 squares, you can verify mostly in 1 lakh what are the primes you can get. So these kind of steps we are going to use in programming. If you are going for a pure maths, in future if you are going for a pure math, programming side also it will be useful. Don't think it won't be useful anywhere, but it will be useful for astrophysics point of view and research point of view. Now, what is the meaning of prime factorization? Anyone? Now we are moving to the next end of the Euclid division lemma. Based on this, we are having some other things. Guys, I can close Euclid division lemma. I can go to the next topic.
Yes, sir.
So, what is the meaning of prime factorization? Anyone can explain what is the meaning of factorization? First of all, let me know what is the meaning of factorization.
Sir,
Yes. What is the meaning of factorization?
sir, it is a process of factorizing a number in terms of prime numbers, sir, like using prime numbers.
No, in terms of prime numbers is different.
So
General
finding the
factorization is
factors-
different. Suppose if I'm having a number 36. 36 I can write as 6 into 6, and 36 I can write as 12 into 3, and I can write as 18 into 2. Yes, correct.
Yes, sir.
So this is called factors. 1, 2, 3. Is 4 is a factor? Yes, 4 is a factor. You can write 4 into 9 also. And after 4, 6 is a factor. 8 is a factor. 9 is a factor. 12 is a factor and 18 is a factor. After that 36, 1 and itself if I am leaving, these are all are called factors. Out of these factors, if you are prime, if you are composites, correct? Guys, am I right?
Yes,
Yes,
sir.
sir.
See, if I'm looking into this, these are the different forms of this 36. But if I'm asking you to write only multiples of primes, that is called prime factorization. You start with 2 into 18, again 2 into 9. This can be written as 2 into 3. Is it possible to write in any other form other than this? See, here I'm writing in different form with the different numbers. If we are having composites, but if I'm asking you to with primes, other than this, any other form can you give for me?
Sir, 1.
You didn't get the question?
Sir, we can take 1, right?
Sir, can you repeat the question once more, sir?
See, if I'm asking you to factorize means I'm giving 4 different forms here. Okay. You can write as 1 into 36 also.
Yes, sir.
I didn't mention whether it can be prime or whether it can be composite. Please factorize. That means I got 1 into 36 is 36 only. 6 into 6 also 36 only. 12 into 3 also 36 only. Correct?
Yes, sir.
18 into 2 also 36. And here, for one answer to one answer, there is no relation. In first answer, I am using 1 and 36. In second answer, I am using 6 and 6. In third answer, I am using 12 and 3. In fourth answer, I am using 18 and 2. In fifth answer, I am using 4 and 9. In sixth answer, I can use 2 into 9. And some other answer I can apply 6 into 3 into 2. These are the various forms of 36. Correct?
Yes, sir.
So all of condensed, but if I'm asking you only do primes means I got like this. It should be only contain primes. Other than primes, you should not mention any number in the factors.
Okay, sir.
So this is only one form I got. What I am trying to ask you, is it possible you can write any other form like this?
No, sir.
No, sir.
No, sir.
That is
No,
only
sir.
fundamental theorem of arithmetic. Got it? What I'm trying to say, guys?
Yes, sir.
Yes,
Can
sir.
you this discussion? Anyone can frame the statement of your own words? This is on our next topic, madam. Almost we've done this one. Rest of all the things are application of this one. This is only our fundamental theorem of arithmetic. What is this theorem says? It's very simple. Every composite number see, you are saying it's composite number. Composite number means it's not a prime, first of all. Every composite positive integer, sorry guys, positive integers, integer n can be expressed as a product of primes. This everyone knows, correct? And this factorization is unique. That is only I am trying to say. What is the meaning of this statement? Madam, anyone can explain? What is the meaning of this statement? And this factorization is unique means what? Apart from the order in which the prime factors occurs. So order is not important, but it will get a unique solution. In which the prime factors occurs. That is, any composite number can be written as some prime number power alpha 1, some other prime number alpha 2, some other prime number alpha 3, and so on, alpha n. Where P1, P2, P3, Pn are prime numbers, alpha 1 and alpha 2, alpha 3 are its indexes. Indexes means any composite number or prime number, anything, any natural number. And this solution is unique. But in case of composite factorization, the solution is not unique. But in case of prime factorization, the solution is unique. This is called fundamental theorem of arithmetic. Suppose if I am asking you to write a number in the form of primes multiplications, you will get only unique solution. You won't get different solutions, which you won't get different combination of numbers. You will get always some number of times of 2 into some number of times of 3 into some number of times of some other primes. This theorem is called fundamental theorem of arithmetic. Understand? You will get a unique solution in terms of primes. You won't get some other prime product, you won't get. Is it possible to write this number with some other prime products? Is it possible to write 36 with some other primes products?
No, sir.
No, sir.
Even however you take, even if you take 4 and 9 also, finally I will get 2 square into 3 square. Even if I am taking 18 into 2 also, finally I will get 2 square into 3 square only. Even if I am taking 12 into 3 also, I will get 2 square into 3 square only. So when I am converting everything into primes, finally I will get an unique solution. That is only fundamental theorem of arithmetic. This fundamental theorem of arithmetic was very much useful for us to calculate the LCM and HCF in a different ways. But this is only one method. I mean, this fundamental theorem of arithmetic, one application is how to calculate the HCF and LCM without using division lemma also. Instead of using division lemma, if I am having 3 numbers or 4 numbers, how to calculate the HCF and LCM, 3 numbers or 4 numbers, using the fundamental theorem of prime factorization. Got it? The statement is clear, guys? Guys,
Yes,
the
sir.
statement is clear? Yes.
Yes.
So I'm going to wind up the class with this discussion. We'll meet in the next class. How to use this fundamental theorem of arithmetic to calculate the HCF, LCM, and relation between the HCF and LCM. How to prove irrational numbers are irrational numbers. Suppose if I'm saying root 2 is irrational number, how we can say it is irrational number? How I can say root 2 is irrational? How I can say root 3 is irrational? That we are going to prove here. I think so far everything is clear. I'm expecting. Anyone having any doubts?
No, sir. All clear.
No,
No, sir.
No, sir.
So I will try
No,
to
sir.
share a small worksheet based on what we discussed so far. Let's see. We'll meet in next class. Bye, everyone.
Thank you, sir. Bye, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
thank you, sir.
Thank you, sir.
Thank you.